In this video, we're going to cover section 1.6, a library of parent functions. This is still unit 1. This is going to be kind of a review section for the most part until we get to the end. So I'm going to go a little bit past the beginning. Pause if you need to copy all this down. There's a lot of information. Okay, so recall that a linear function has the form y equals mx plus b, or you can also say f of x equals mx plus b. We're going to go ahead and introduce this with, instead of using m, using the letter a, simply because when we get to quadratics and other functions, we do have a format of an ABC deal going on. So it's the same thing, okay? So ax plus b would be considered our m, which is known as the slope, okay? And of course, we know this from before that the b number, whatever this is going to be our y-intercept. So our y-intercept would be 0, comma, whatever that is. Okay? The characteristics of this function, remember this is our parent function, f of x is equal to x in general, and I'll talk about that in a bit, is that the domain is all real numbers, okay? Meaning every number is going to be accounted for, okay? And the range is going to be all real numbers as long as your slope is not equal to 0. Okay, so if m is not equal to 0, this works. If m is equal to 0, here's a note. Okay, if m were to equal to 0, then we would have to plug in a 0 here, and that would give you 0 times x plus b, which means that this would be gone, and you would just have y equals b. So when this happens, then your y is actually going to be just one value, and we'll talk about that in a little bit. Okay, the graph has an x-intercept at this value here. So this is a quick way to get that x-intercept. Just plug it into this formula, and a y-intercept at 0b. Okay. More properties, the graph is increasing when m is positive. So in other words, if your slope is positive, then the graph is going up, just like you see here. Remember that we go from left to right, so you can see here the little green line going up. And this is just reference, guys. This we've already covered, but it's just kind of review because we do have to talk about all the characteristics. And it's decreasing when m is negative. So when m is less than 0, that means that the slope is negative, and that means it's going down. Okay, so this one is positive, this one is negative. Okay, and then the last one is constant when m is equal to 0. So when m is equal to 0, the line just goes straight across horizontally, and that means that there is no slope. It's just going to be, a nice easy stroll in the park if you were walking on this line. Okay. We're going to go ahead and start with an example on how to write a linear function if given in this format. Okay, so it says write the linear function f, okay, for which f of negative 2 equals 6 and f of 4 is equal to negative 9. So all we have are these weird notations here. I'm going to go ahead and start you off with step 1. When we're writing a linear function, you need two things. You need the slope and you need the y-intercept. So if you're given points and a slope, you can probably figure everything else out. If you're given points, you can figure out the slope. So these two things are points. This one right here is the same as negative 2 comma 6. Okay, that's this point right here. It's just written a little bit differently. And this one would be 4 comma negative 9. So from this right here, we can rewrite this like this if it's easier for us, okay? And then from there, I'm going to go ahead and label my x1, y1. So this could be x1, y1, and this could be x2, y2, okay? Okay, and the reason I'm doing that is because I'm going to find the slope first. Remember that the slope uses these four numbers, okay? So just kind of a reminder, your slope is equal to y2 minus y1 over x2 minus x1, which is the difference in y divided by the difference in x. So I'm just going to plug this in. I'm going to go a little quickly here because we've done this before. So we're going to have y2 is negative 9. Okay, so negative 9 minus y1 is 6. Okay, so I'm using these two first, the y's, divided by the x's. So x2 is going to be my 4 here, okay, minus the x1, so negative 2. Okay, you just want to double check, make sure that these two are the same two that go together here. These two are the ones that go together here. We're good to go. So we're just going to evaluate this real quick. Negative 9 minus 6 is negative 15. 4 minus negative 2 is the same as 4 plus 2, which is 6. And I can simplify this by division by 3. So if I divide by 3, the top and the bottom, or the numerator and the denominator, I get negative 5 over 2. And this would be our slope. Okay, this is the slope. And now that we have the slope, which is also our m, okay? Now that we have our slope, we can go ahead and use the point slope formula to find the actual equation, because we want to know the y equals part. What is this, or f of x equals if you want. So I'm going to go ahead and do step 2 now. So step 2, okay, is to use the point slope formula, which we learned about last week. And if you don't remember it, that is perfectly fine. I'm going to write it down for you here. No worries. Okay, so there it is. It's the y minus y1 is equal to m times x minus x1. Okay, now the beauty about this is that we actually have 2 points that we can use. Remember that when you're using this formula, you only have to pick one. So I'm gonna pick this one just because I already have it labeled x1, y1, so it's just easier for me. So we're gonna go right into it. We're gonna have y minus y1 is going to be this number 6 here. Okay, and then my m is a fraction, so negative 5 halves. X minus x1, x1 is negative 2. Okay, so I'm going to save myself some work here. That's going to turn into a positive because those two negatives make a positive. And I'm going to go ahead and distribute next. So from here, I would go ahead and distribute this negative 5 halves. So I'm going to have negative 5 over 2x. Okay, and then when you're multiplying a fraction times something else, remember this is positive 2 now, you have to put this over 1, and you just multiply the top with the top, bottom with the bottom. So negative 5 times 2 is negative 10. 2 times 1 is 2. Okay, remember we still have this y minus 6 over here. And I'm going to go ahead and reduce this. If it stayed as a fraction that you can't reduce, then yeah, you're going to have to find a common denominator. But this one, luckily for us, reduces. So this is going to be negative 5 over 2x minus 5, because 10 divided by 2 is 5. Bring that down, okay, minus 6. And now I just have to add the 6 to get rid of it on the left side. Okay. So it looks like my answer is going to be y equals negative 5 halves x. Negative 5 plus 6 is positive 1. And if we wanted to be a little bit more correct, because, well, this was an f of x function, right? You would go ahead and write it as f of x. So f of x is equal to negative 5 half x plus 1. Hopefully I didn't make any mistakes this time. I know on one of these before I did something weird with the signs. So there we go. If you catch something, let me know. Okay. All right. That's it for that one. That's kind of review. Okay. So now we're going to talk about all the different functions that we have to at least be somewhat familiar with. Okay. Go ahead and copy these down now. These are special linear functions, and there are 2 of them. Okay, so remember, we're talking about the parent functions here. So these are like the parents of all the other lines. We have the constant function, which is a straight horizontal line that goes across at any point on the y-axis. Okay, and it's f of x is equal to c, where c is whatever value it's going through. Okay, so in this case, c would be equal to 1. And then we have our identity function, which is our mother of all linear functions. Okay, this one is just f of x is equal to x, and it is a diagonal line that goes perfectly through the origin. Um, every point is kind of matched, so we have 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2, and so forth. The x-intercept and the y-intercept are also in the middle, so 0, 0 is going to be our intercepts for this parent function here. Okay, couple of properties for these guys. Their domains are the same. So the domain is everything, all real numbers, because they both go on forever, left and right, okay? The range is a little bit different because for our identity function, so for this guy, it is going forever up and down, so it's also going to be all real numbers. This one is only going through that one point right here on y. So y is only going to be equal to this number, whatever that is. So for the range, y equals c, whatever c is. Our slope is equal to 0 for this one because, again, if you were walking on this line, it would be a nice, easy stroll. You don't have to, no heavy breathing going up a hill or anything like that. And it's constant. The slope for this one, oh, sorry, I hit this by accident. There we go. All right, the slope for our identity function is 1, and it's always going to be increasing because, again, if you're going from left to right, so you're coming this way, okay, you'd be climbing up, not falling down. And I did want to make a note about something I didn't mention in the other video, simply because it wasn't really part of our text, but you did have some homework problems on it, surprisingly. So I'm going to go ahead and mention it here. I went ahead and added that f of x is greater than or equal to 0 on the interval 0 through infinity. So what that means, if you didn't get it the first time in class, is that this graph right here, this graph is above the x-axis from here to infinity. So in other words, if I were to cover, let me use my little paper here, if I were to only look at the top of the x-axis, it would be these two quadrants, right? So the only place that I have my graph in that part would be from here, from 0 to infinity. And that's what this means right here. From 0 to infinity, the graph is above. Okay, the graph that we drew here is above the x-axis. It's below, so this notation here means below on the other side. So on negative infinity to 0, so on this side over here, okay, if I look at the bottom, negative infinity all the way to this point here, 0, is going to be below the graph, okay? So that's what that means, above and below. This means above, this means below, okay? And we'll practice this quite a bit, so you'll get used to it. Next type of function that we have for our parent functions are the squaring functions. I actually have never heard it be called this. I usually just call it a quadratic, but I guess because it has a square. So either way, it's fine. This one you should be familiar with. It is a U-looking shape. It is called a parabola, and it has a lot of properties that we're also familiar with. So I'm going to look at the properties first. Well, I guess I can do them at the same time. Or you can see the whole page and copy at the same time if you need to. This is review, so if you don't want to listen and just kind of copy, that's fine too. Um, Domain is all real numbers because it's going forever left and right, okay? The range is going to be the set of all non-negative real numbers. That means that it's pretty much from 0 to infinity. And if you wanted to write that, you could do that right here, 0 to infinity. Okay, it's the positive numbers and 0. This is also considered an even function, which we learned about in the last unit or so, meaning that if you were to fold it in half, so remember this paper from before, if you were to fold this paper this way, okay, they would land on itself, assuming, the picture was drawn perfectly, which is also known as y-axis symmetry, okay? The function is decreasing on negative infinity to 0. So what that means is, remember, we had the arrows from before. It's decreasing from everything on this side all the way to this point, and then it's increasing on the other side. So this side, it would be increasing between 0 and infinity. So 0 to infinity, the graph is going up. And finally, it has a relative minimum at 0, 0. Okay, this is our relative minimum because it's the lowest point in this region, which also happens to be our x and y intercept, 0, 0. And last but not least, I know I just said that, but I forgot this one. The graph is going to be above the x-axis. So the graph f of x is positive. Remember, this is f of x. F of x is going to be positive or equal to 0 the entire time. So if I were to say, well, where is the graph on top of the x-axis? Well, the entire graph is on top of the x-axis. So if the entire graph is there, that means that the entire domain is going to be our indicator for this. Okay. And if I asked you where it was below, you would say nowhere because there's nothing below, just blankness. Okay. All right, more properties. A few more. And we'll do some actual work. You're all waiting to do some work. We have two different functions here. Okay. The cubic function and the square root function. You can ignore that little scribble. I think I put functions with an S. So I don't have a whiteout right now, so I just scribbled it out. So it's cubic function and square root function. I'm going to look at this one first. I'm going to cover this guy so we're not distracted too much. We have that f of x is equal to x cubed. Okay, that's cubic, so that's what the 3 is for. And here's what it looks like. I'm going to go ahead and try to get all this on the screen here. It kind of looks like a snake-looking thing. You should recognize this from our discussions earlier on symmetrical about the origin, because this one actually does have origin symmetry, and it is considered to be an odd function. And you can see that right here on the third characteristic. Okay, the domain is all real numbers, the range is all real numbers, so that's kind of nice because we don't have to, think too much about that. And the graph is increasing on the entire domain. So if we were to, again, if we were to be going from left to right, if you were some little person, trying to go through this graph, you would have to be, it'd be pretty steep, but you'd be going up the entire time. Oh, I think I chose the wrong color. I think the increasing I did with pink. Or whatever, it's going up. Okay, so it's increasing the entire time, which is why we have it on the entire domain here. Okay, x and y intercepts are also 0, 0. And finally, for this function, ignore everything else over here. We have that it is above the x-axis from 0 to infinity and below the x-axis from negative infinity to 0. So it's kind of like the linear function that we first saw, where the top of this graph is going to be this piece. So from 0 to infinity, that's where it's positive. And the bottom, this is where the graph is negative. So from negative infinity to 0. Okay, and that's what this means again. I'm going to keep writing that above and below to kind of remind you. Okay, so those are the properties of our cubic function, our parents. And now we're going to look at the properties of our square root parent function. So this guy is, I'm sure you've seen it also. It's f of x is equal to the square root of x. The domain and the range are going to be the set of all non-negative real numbers. So just like the one over here, not this one, previous one, I think it was the quadratic, you're looking at 0 to infinity, okay, for both the domain and the range. I'm just going to like squish that in here, 0 to infinity. That's what this means right here, the set of all non-negative real numbers. Because if it's non-negative real, that means it's going to be positive, right? And it's going to include 0. This one is also increasing on the entire domain. So here is the graph that we see here. And I forgot to put a parentheses on my infinity. There we go. I was just trying to see if anybody caught that. This one is increasing the entire time because, again, if we were to follow it, we would be going up. Granted, it's not going up very fast, but it is still increasing. And of course, just like most of our parent functions, the intercepts are at 0, 0. For our graph analysis here, this would be positive on the interval. Why am I getting greater than 0? Okay. This is greater than or equal to 0 on the entire domain also, because if we look at the graph on top of the x-axis, well, the entire graph is on top of the x-axis. There's nothing below the x-axis, so it's not going to be less than or equal to 0 anywhere. Okay. All right. I think we have one more that you might be familiar with, and this is called the reciprocal function. I think we often called it rational last year if you were taking algebra 2, but the correct terminology is actually reciprocal if you're going to be more, technically correct. So the reciprocal function is called the reciprocal function because, and I'm just going to write it right here, f of x is equal to a fraction of sorts, 1 over x. Okay, so I'm going to bubble that. I know it's kind of squished here. And 1 over x is the reciprocal of x over 1, which is our identity function. So this is the reciprocal of that one. And it has a lot of interesting properties. Okay, so you have seen this graph before. Notice that it kind of looks like it has two pieces. So because it has the quote unquote two pieces, the domain and the range are both, two pieces. The first part of the domain is negative infinity to 0, so it's everything over here, and 0 to infinity, everything over here. Same thing with the range, everything on the bottom and then everything on the top. And we have to do it this way because this graph actually does not have any intercepts. So right here, there are no intercepts, okay? Anywhere actually. If you look at all the axes, there's no intercepts anywhere. So we really can't connect it. We have to do two different pieces, okay? This function is also odd because if you were to fold diagonally, remember how I did it with the paper that one time? It's going to land on itself. Okay? It has origin symmetry. It's decreasing pretty much the entire time, which is a little bit baffling for some people. But when you're thinking about decreasing, increasing, you have to think about going from left to right. So again, if you were a little person walking on this line, you would be sliding all the way down, so you'd be decreasing here, right? This would be going in a downward motion. And then if you started up here, okay, so now you're over here on this side, you still have to go left to right. So again, you would be going in a downward motion. Even though over here it's going to go, not so, it wouldn't be that much of a fun slide if you were at this point, but it's still going to be going down slowly, slowly, slowly. Okay, so it's decreasing everywhere on the entire domain. And then just like the ones before, we have that it's positive over here, so from 0 to infinity, and negative, so it's below the graph from on this side. One thing to note is that I did not equal it to 0 here, like I did in the other ones, because this one does not equal 0, which takes me to the final thing here. Um, we actually have something called asymptotes at those points. So we have a vertical asymptote at x equals 0, which is this one right here, and a horizontal asymptote at y equals 0. I'm not going to focus too much on that because we will see this function later, and it'll be a lot more focused detail on that. But these are the main properties of this graph. Okay, so we're going to go ahead and move on and do some actual work now. So hopefully these notes have been mostly reviewed. Okay, go ahead and take a moment to copy. Let me see if I can get this all on the page. I'll get what I can get, and then you can pause if you need to. This is called the step function, and it's also known as the greatest integer function. It's known by its really interesting look. It looks like a staircase if you were to graph it. Okay, so the way this graph works is anything that is put into this little box, it's kind of like brackets, okay? And actually they look more like kind of like doubled, but I'm not being very specific here. But they look kind of like that. And the way it works is anything that's put in here, you take the integer so like kind of like a whole number, okay, that is greater than or equal to that number. Okay, so this number is greater than or equal to whatever the integer comes out. Maybe I'll just show you an example because that's a little bit confusing. So here we go. I'm sorry, the greatest integer less than or equal to. That's what I meant to say. I don't know what I'm reading. So here's like some examples just numerically so you can kind of see how it works. If I were to plug a -2 in here, well, -2 is already a whole number, so we don't really have to think about it. It's just -2, okay? So any whole number that you put in here, also known as an integer, would be the same output over here, okay? Once we start throwing fractions and decimals, though, you have to think a little bit. You want to find the integer that is less than or equal to this number. So I have a little number line here just to kind of show you what I mean. And what we're going to do is we're going to find this -1.5. So -1.5 would be about right here. Okay, that's -1.5. And we need to find the integer that's closest to this but is less than this number. So remember that less means we're going to be going to the left. So it's one of two choices. It's either going to be -1 or it's going to be -2 because those are the two integers that this number falls between. Since it has to be less than or equal to this number, Well, -2 is less than 1.5, so the answer would be -2, okay? So another way to think about it is, what's the closest number to this that is on the left side? Okay, so we'll do some more examples of this in a little bit. Okay, let's go ahead and talk about the characteristics now because they're pretty interesting. Like I mentioned, it does resemble a staircase. Okay, the domain is going to be all real numbers, so that means that it goes across all the way left and right. The range is the set of all integers. So integers means like -1, 0, 1, 2, 3, 4, no decimals, no fractions, no irrational numbers. Okay, these are integers you can actually count with your fingers. Okay, and it's represented by this Z looking thing. It's Y is an element of the Z or integers. Z means integers, just like the R means real numbers, Z means integers. Okay. It has a y-intercept at 0, 0, and it has x-intercepts. Notice that there's multiple ones on the interval 0, 1. So this actually kind of has like a whole little line that is all x-intercepts. The graph is constant, meaning that the slope is 0 between each pair of consecutive values. You're going to see the graph right now and see what I mean. Okay, and the graph jumps. It looks like it jumps from one point to the next after each integer value. So here is what this graph looks like. And I'm sure you've seen it maybe once in your life. If not, then congratulations. Here's the step function. Okay. And it's called the step function because they look like steps of a staircase. So let's kind of look at this a little bit. Notice that if you were to think about, if I were to get this paper and just squish it inward this way, all of these would connect, right? They would connect into like a single line. Please note that it's going to keep going. Okay, I just, I didn't draw the rest of it, but this little pattern keeps going on forever and ever and never, never, ever, both left and right. So if I were to squish them all together, you would see that it'd be one humongous horizontal line. And that is why the domain is all real numbers, because it does cover every single x value. The y values, however, since we can't just squish it, okay, that's not really an option. If you look at the y value, you see all the gaps. We don't have any y values in between here, here. We're missing all those gaps, and in fact, we only have y values where the line is horizontal. Okay, so and those happen to land on the integers on 1, 2, 3. Well, that's backwards. -1, -2, -3, 1, 2, 3 on this side, and so forth. So that's what I mean by it has the jump and it has the consecutive, what did I say? Consecutive values between each pair, okay? I'm gonna show you how to graph one of these because you are gonna have to graph something like this, okay, in one of your assignments. So at this point, go ahead and copy this down. And again, if you still haven't gotten that download for that calculator, I highly recommend it because you're going to need it for this this graph. Unless you can find something else that works, then let me know. We can share with the class. Okay. So here are the steps. We're going to go ahead and do y equals math. There's a math button, number, option 5, and then you're going to see this like this is going to pop up. Okay. You type in the function, close the parentheses. You have to change this little mode on the side to dot mode. So I'm going to do an example just to kind of show you. Let's say and I can do the one that's down. I'll do the one that's down here just so we can see. So here's my calculator. Hopefully you can see it. And we're going to follow the steps. So it says to press math, and it takes you to this little like menu. So we're going to go to number, and then we're going to press number 5. Number 5 has that integer that I'm looking for. Okay, so there it is. Okay, int parentheses, and I'm going to go ahead and put my x in there, close the parentheses, and then do, let's see, what's that, +1. I'm just putting the one I have underneath, which is our next example. Okay, so there it is, and that's all the way up to step 3. Okay, now we have to go to step 4. It goes go to the far left of y1 and change to dot mode. So here, this is, I won't touch it because I might mess with the screen, but this is y1. This little piece over here is where we can change the dot mode. Right now, it's just on the line mode because it's showing the entire line. So So we're going to go all the way to the end. And to change that, you just press enter over and over until you get what you want. So I'm pressing this over and over, and there are my dots. They popped up just how I wanted them to. Once that comes out, you're going to graph, okay? And there is my step function. I had been messing with this earlier, so let me go ahead and zoom it back to what it was. Okay, there is the step function. Look like steps. You can zoom in to look at it. Zoom in better. Okay. This one, notice this one doesn't start at 0 because I did x step and then plus 1. So depending on what function you're using, it might move a little bit. Okay. So that is what it looks like, and that's how you graph one. Okay. So we're going to go ahead and do a couple of examples now algebraically, just so we have the practice. We have some evaluate problems here. It says evaluate if f of x is equal to step function of x plus 1, which is the one I just graphed actually. Okay, so we're going to look at the first one. Here's how it works. We would do f of -1 because that is our x value. Okay, so this is our x value right here, -1. I'm going to plug that -1 into this little box. So here is -1 and then plus 1. Okay. Remember what I said earlier about that if this number in here is already a whole number, then our job is pretty much done. It stays the same. So -1 is still equal to -1. So I'm just going to bring the other one down. -1 plus 1 is 0. Okay. Next one. Hopefully you should know the answer for this one already. So f of f of 2 is equal to the step function of 2 plus 1, okay? And again, this one is already a whole number for us, so this of 2 is just 2. Bring down the 1, 2 plus 1 is 3, okay? And last but not least, we do have a fraction because we know how much we love those. So f of 3/2, okay, is equal to, I'm going to put my 3/2 in the little box, okay, plus 1. On this point, if you want to change this to a decimal, you can because you want to know, remember, you have to know what integer is to the left of it. So I probably would change it to 1.5. Okay, just because visually on a number line, 1.5, I know where that is. I'm not really sure where 3/2 might be. Okay, so 1.5, what integer is smaller than 1.5? So it's either going to be 1 or 2. Remember, it has to be less than this number. So this one is going to be 1. Okay. Oh, I do not know where that 5 is coming from. So 1 plus the 1 that's already here, okay, is 2. So I'm going to go ahead and match up just so you can see what was what. This guy became 1, okay, and then 1 plus 1 is 2. This 2 over here, it stayed as a 2, and then 2 plus 1 is 3. -1 stayed as a -1, and -1 plus 1 is 0. Okay, and that's basically it, guys. Okay, for this particular function. We have one more example because we do have to go over piecewise, and it's really too bad that we can't go more into this one because this topic is really there's so much you could do with it. But I'm gonna show you how to graph a piecewise function. It's not exactly a parent, but it is kind of important for some of the stuff that's coming up. So recall that a piecewise defined function is two or more equations over a specified domain. I believe we did see maybe one or two something similar to this in the past, but I'm going to show you how to actually graph it, and I'm also going to show you how to use your calculator to graph it. That way you can check your work, okay? So we have this example 4, and it says sketch the piecewise function. So the way these work is you have more than one piece, and therefore you have more than one expression here, okay? Now, usually if it's only two of them, it's not too bad. If it's three, then you do have to think a little bit more. But luckily for us, it's only two, so we're only going to have to worry about two pieces. Okay, so I'm going to go ahead and kind of color code these. My first piece, so 2x plus 3, it looks like the slope is 2. Okay, so m equals 2 or 2 over 1 if you want to think of it as rise over run. And my b is equal to 3, which means that the y-intercept is going to be at 0, comma 3. Okay, for my second function or my second piece, okay, this guy, it looks like my m is equal to -1 because there's a negative in front of the x, so there's always an imaginary 1. So it's going to be -1 or -1 over 1 if you prefer that. And my b will be 4, 4, 0, comma 4. Okay. Now the thing we have to consider here is this right here. So these guys are the domains where these graphs exist. Notice that they both kind of center on 1. So what I'm going to do here on 1 is I'm going to go ahead and do kind of like a dotted line just for my own knowledge here because I know that one of the graphs is going to be on this side and one graph is going to be on this side. So something that helps me with this kind of problem, let me zoom out a little bit so we can see the whole thing, is to kind of label where the graph is going to go. Okay, so according to, let me see, according to this information, it says that 2x plus 3 is there when x is less than or equal to 1. So x is less than or equal to 1. This means everything on the left side. So this entire piece right here, okay, is going to be 2x plus 3, okay, because all this is less than or equal to 1. The other side, x is greater than 1, is on the right side. So on the right side of 1, bigger than 1, we have this guy. So I'm going to go ahead and just label this for myself, negative x plus 4. Okay, so that means that this line is going to be take over this piece, and this line is going to take over this piece. So that's the first thing you want to do. Okay, then we're going to go ahead and draw the lines, probably using a pencil for sure, because, well, you'll see what I mean in a bit. Okay, then we'll go over it in color. So for this guy, I'm going to start with my y-intercept. So that's at 0, 3. So 1, 2, 3. So that's right here. Okay, there's a point there. And the slope is 2 over 1. So that means I'm going to go up 2 and then over 1. My graph's a little bit crooked, but that's okay. And then down 2 and over 1. So it's going to be kind of like, hopefully yours is straighter than mine, kind of like that, something like that. I don't know, something like that. But we're just sketching it. So even if it's not perfect, that's fine. Okay. Now, on the point of intersection, I guess you could think, or where these lines kind of coincide, we have to see if this point is going to be open or closed. Okay. So according to the what I have up here, since we have an equal sign, that means that this one is going to be the closed circle. So I can go ahead and leave this one as a solid circle. Okay. Notice that I didn't go past this point because this territory belongs to my blue function. Okay. So I can only stay to the pink function here for my first one. Okay. For the second one, we're going to go ahead and do the same thing, but now we have to use the different, slope and intercept. So for this one, it looks like our intercept is 0, 4. So here's where it gets a little tricky, okay, because 0, 4 is right here, okay, but that's in the wrong territory. Like this guy is not allowed to go over here. So I'm going to do it lightly because I still need it as a guide, okay? And then my slope for this one is -1 over 1, which means I'm going to go down 1 over 1, okay, down 1 over 1, down 1 over 1. So it looks like this graph is kind of like this maybe. But notice that I stopped here because I remember this is the point of no return. You can't pass here. So I'm going to erase the one I had over here. I just used that for a guide to get the rest of the line. Okay, now you will notice that I left this as an open circle because usually in piecewise, and probably most of the time, otherwise it wouldn't be a function. If one dot is solid, the one underneath it is not going to be solid because the moment that these two are solid, it's going to fail the vertical line test. Okay, and luckily for us, you can see right here that this is an open circle, so that further validates that this one should be an open circle. Okay, but yeah, that's pretty much it. We have our graph. Now that I have it nice and neat, I'm gonna go ahead and just, outline it a little bit in color so I know this is the first graph and this is the second piece. Okay. And to prove that we did this correctly, I'm going to show you how to do it on your calculator because I know that we're going to want to check to make sure we have the right graph and you don't want to mess this up, especially if you're using pen. So for the calculator part, what you're going to do, okay, is you're going to go back to that y equals and you're going to go ahead and do two different y equals because we have two pieces, so we need two of them here. So you want to put them in parentheses. So 2x plus 3. There's the first one. That's this one right here. But then you have to put the condition also. So the condition is another parenthesis. So I'm going to do another parenthesis. And then I'm going to go ahead and pick my x. And for this symbol, okay, we're going to go ahead and do second math. So where it says test, that little yellow test, you want to get that. So second math. And there are my symbols, okay? So that one is, let's see, what was it, less than or equal to? So we're going to go ahead and go down to less than or equal to, enter, 1, close the parentheses, okay? So now this looks like what I had here, and then we do the same thing for y2. So that one is negative x plus 4, okay? And then our conditions. So x is less than, so second math, this one, 5. And it was a 1, close parentheses. And once these are good to go, okay, you want to go ahead and make sure you go back to the end over here and put these in dot mode again, just like we did with the piecewise. Okay. Did it go? I'm not even sure if it went. I don't think it did. Okay. So there's that one. And then I'm going to do the other one. And then we're going to graph it. This little thing you saw over here, that was because it was loading. I'm going to go ahead and put the zoom back to normal. So that's number 6, standard. And that will show our entire graph. Oh, what happens? What happened here? Let me see. Did I forget something? Oh, I did forget something. This was greater than, not less than. That's why. So see, make sure you do check your work. Okay, because then you might make a mistake. It's a good thing we caught it. Okay, let's try it again. And there we go. Okay, so there's our graph. If you wanted to zoom in, you could just press zoom in. And I'm going to move that little, there's like a little plus sign that pops up. You can move it closer to where you want it to zoom in. And we can get a better view of what's going on there. All right, that's it, guys. If you have any questions, let me know. As always, thank you.